Welcome to True Projects. In this video, we are going to explain about the project title Software Defined Network for Enhanced Network Management and Optimization. Before diving into the execution, let me give you an overview of the project. Let us first understand what Software Defined Network is. SDN stands for Software Defined Network, a networking architecture that allows centralized control and management through software applications. It enables programming of network behavior and device management via open APIs, providing efficient and flexible network operations. SDN, Software Defined Network, separates network control from data forwarding, enabling centralized programmable management via software applications. It enhances connectivity, speeds up deployment, improves security, and provides better control and speed. Components include SDN, software defined network applications, controllers, and networking devices communicating through APIs for efficient operations. The project aims to use SDN, software defined network principles, and data analysis to detect and classify network traffic as either malicious or benign, enhancing network security through accurate identification of threats. Traditional network security relies on static rules, IDS, that is intrusion detection system, IPS, intrusion prevention system, and manual management. However, these methods lack flexibility, struggle with scalability, suffer from delayed responses, and offer limited network visibility, hindering effective threat detection and mitigation. The project begins with importing an SDN dataset, followed by exploratory data analysis and data visualization. Feature selection identifies relevant predictors, while SMOT addresses class imbalance. Classification task utilizes linear regression, Navy Bayes, XGBoost, that is extreme gradient boosting, and CNN, convolutional neural network, for network traffic analysis, aiming to enhance network security through accurate traffic classification. The project benefits network administrators with enhanced security tools, organizations with improved security and risk reduction, and researchers with insights into SDN's effectiveness. Its importance lies in heightened security, operational efficiency, and enhancing innovation in SDN technologies. Flask, a Python web framework, is integrated to offer a user-friendly web interface for controlling and managing the SDN-based network optimization system, streamlining deployment and user interaction. To implement this project, we need software and hardware requirements. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, backend framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project to classify network traffic as either malicious or benign. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here the XGBoost outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, this is the data set. Let us open this. So in this project, we have utilized the SDN dataset, that is software defined network dataset. So here these are the different features, that is DT, switch, SRC, DST, packet count, byte count, duration, total duration, flows, packet tins, and more. So here this is the target column in which we are having two labels, 0 and 1. 1 means malicious or network is not normal, and 0 means benign and network is normal. This data set is pre-processed and then it is used to train the models. Now let us close this data. So here this is the model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And here, this is signup.db file. This file is the database file used to store user information. And here we have the test cases text document. Let us open this. So here, these are the test cases which we will use during the execution. So first we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So if we are new users, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered. So click on sign in button. So here we need to enter the username and the password, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to enter these values, and after entering these values, the application will classify whether the network traffic is malicious or benign. So before entering the values, let us understand what these parameters are. So here the first one is packet count, number of transmitted packets indicating data volume. And second one is byte count, total data transferred in bytes essential for bandwidth management. And the third parameter is protocol, communication rules used, that is whether it is UDP, TCP or ICMP guiding network behavior. Flows, series of packets with shared attributes managed dynamically for efficient routing. And the next one is DT, which is date and time. Timestamps for analyzing network traffic patterns and events. Total duration, cumulative time for events assessing network efficiency. Coming to the next one, which is duration, time for individual events, pinpointing delays or issues. Packet rate, speed of packet transmission, indicative of network congestion. And the next one is packet per flow, average packets exchanged per flow, guiding network optimization. So these parameters aid in effective network management and optimization within SDN frameworks. Now let us enter the values of these parameters from the test cases. So here, these are the test cases which I have shown you during the explanation of the code folder. So from here, we will enter the values. So first, let us enter this set of parameters. So here the packet count is 59568, byte count is 3216672, and protocol is TCP, flows is 5, DT, that is date and time, is 25391, total duration, which is this, duration is 187, packet rate is 312, and packet per flow is 9376. So here I have entered all the values. Now click on submit button. So here we can see the outcome, that is malicious or traffic is not normal. So it means that the network is not normal. Malicious traffic is abnormal network behavior, including unauthorized access and malware distribution, identified through anomaly analysis or known signatures to protect network integrity. Now let us enter another set of parameters and check whether the network traffic is malicious or benign. Click on try again. So again, from the test cases, let us enter the values. So here, these are the test cases. Now let us enter the set of parameters. So the packet count is 864, byte count is 84672, protocol is ICMP, flows is 9, DT, that is date and time, is 31131, total duration is this, and duration is 883, packet rate is 0, packet per flow is 29. So here I have entered all the values. Now click on submit button. So here we can see the result, that is benign or traffic is normal. It means benign traffic refers to typical legitimate network activity conforming to established patterns, contrasting with malicious behavior, and is identified through routine monitoring for security and operational integrity. Now let us enter another set of parameters. Click on try again. So again, from the test cases, I'm entering the values. Now let us enter the set of values. So here the packet count is 108633, byte count is this, protocol is ICMP, flows is 7, DT is 30741, total duration is this, duration is 391, packet rate is 264, packet per flow is 7949. So here I have entered all the values. Now click on submit button. So here we can see the result, that is malicious or traffic is not normal. So malicious traffic is abnormal network behavior, including unauthorized access and malware distribution, identified through anomaly analysis or known signatures to protect network integrity. Now let us enter on the set of parameters. Click on try again. So let us enter the values from the test cases itself. Now let us enter this set of values. So here the packet count is 90333, byte count is this, protocol is UDP flowsys 3, and DNT, that is date and time, is 11425. Total duration is this much. Duration is 200. Packet rate is 451. Packet per flow is 13534. So here I have entered all the values. Now click on submit button. So here we can see the outcome, that is benign or traffic is normal. Benign traffic refers to typical legitimate network activity conforming to established patterns, contrasting with malicious behavior, and is identified through routine monitoring for security and operational integrity. So in this way, we can enter more sets of parameters and see whether the network traffic is malicious or benign. Now click on logout link here. The software defined network project concluded with notable enhancements in network efficiency and flexibility, driven by successful implementation and analysis. Key findings underscored improved resource utilization and reduced latency despite encountered challenges. Recommendations for future efforts include exploring advanced SDN features and integrating deep learning for more intelligent network management, highlighting the project's transformative impact on network optimization.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.